Hey there, Hashi Talks Build. I'm Scott McAllister, developer advocate at ngrok. Today, I want to take you through our journey of building Ingress into Kubernetes with ngrok. This is not meant to be a sales pitch, but I will be talking about our company, its features, its products, because you need to know the context around why we made the decisions that we did. Because we're going to be talking about the trade-offs that we went through in order to provide the features that we needed for ourselves, but also for our customers. Now, your needs, they might be different, but this is our story, and hopefully you can learn from some of the experiences that we had. To give you some background and make sure that we're all on the same page, I'm going to talk a little bit about ngrok, describe what it is, and give you a sense for what we provide and why we made the choices we did. Then I'm going to talk about containers and Kubernetes to cover some of the terminology and concepts. That way we're all on the same page. And finally, I'll bring all those together and talk about how we brought everything into one nice solution. So the story of the day is trade-offs. You'll be hearing me talk a lot about trade-offs because in every project, we have decisions that we make. We have decisions that are based on our needs, whether they're for us or they're for our users. But the philosophy we took was, if it works for us, then why not for our users as well? So think back to a time where you created a new project. It was awesome. You were so excited about it. You had everything in it that you thought could possibly be great. And you knew that the moment a user got their hands on it, they would also love it as well. No one could tell you that it was ugly. No one could tell you that even if it was green and had little green arms sticking out of it, that it was a bad thing because you knew it was awesome. It just had to get into a user's hands. But that was the thing. That was the issue. It needed to get into a user's hands. And to get from your machine onto a user's machine, or at least onto their device for them to use it, there's a gap. You have to set up some network connectivity settings to get your application online so that people can use your application, so that you can have customers, and so that you can actually continue building your application. To do that, you might have to think about, well, let's think about setting up some NAT, and maybe configuring DNS or messing with certificates. And that's just for this one service. What if I add more services, or I take my application from my laptop and take it into my office network and start figuring out, okay, well, now I have settings I need to think about getting through a firewall or a VPN or all these other configurations that you need to be an expert on in order to get your application online. Not only online and accessible, but also online, accessible, and secure, so that you can have secure traffic with your application. Well, that's where ngrok comes in. ngrok is a service that allows you to not have to worry about that connectivity. No matter where your service is running, your network settings are the same. You point ngrok at your service, and ngrok does the rest. Essentially, you're connecting to ngrok, and ngrok will connect your application to the world. And it traditionally does that as an agent that runs in your command line. ngrok does that magic where it takes the port you specify on your machine and makes it accessible to a URL that either you specify or the ngrok returns for you. You give it a command like this. It says ngrok, say HTTP, which is the protocol you want, and then on port 80. So we said port 80 here. We specified a domain, and we get a response that says, here is traffic that's going to be going to this URL. We'll route it to that port on your machine. Now, the reasoning behind all of this is an idea that's shared by our founder, Alan Shreve. If you think about all of the other parts of our development lifecycle, many of them have been abstracted out. Very few of us are programming in low-level languages that are close to bare metal. We're working on those high-level programming languages. And then even then, many of our front-end engineers are saying, well, yeah, JavaScript's awesome, but why not use these frameworks as well? And many JavaScript engineers are using frameworks like Angular, or React, or Vue. Again, abstracting out some of the tedious parts of using whatever the lower language they're abstracting from. If you're working with an API, say, very rarely are you making HTTP calls and parsing JSON. You're connecting to an SDK that says, hey, I'm already working in Java, so let's keep working with Java objects and make sure that we can just have this connectivity between me and another system, rather than saying, let's make this HTTP call. Then let's parse this JSON into Java objects. An SDK should be written and probably abstracting out that API traffic for you. Same concept with ngrok and our network connectivity. You have all these important settings that need to be configured so that your application is online in a secure fashion. Let us handle all of that, and you focus on getting your application and making it work. We'll make it environment independent, so that way you can have that same connectivity from your laptop or in a data center or in a cloud provider. All those things are available through ngrok. Okay, that's enough of my sales pitch. Now, going back to your application, our application is growing. People love it. You were right. The market loves it. People love it, and they're using it, and they're asking for more features. So you need to add more services. So to do that, you probably need to start thinking about, okay, if my services, if I'm going to have more of these, I need to start thinking about how to build this in a more constructive sort of way. So why don't we do that with something called containers? And when we do that, all of our application code and the dependencies are run, they're stored inside of the container. Containers are their own portable computing environment. They contain everything you need to run the service. Containers run on an abstracted layer above the host operating system, which makes the container extremely portable. They just run in the container runtime, which is something like Docker or Containerd. Now, most applications will have multiple containers running, especially as the application adds features, other services, or even scales. And that's where Kubernetes comes in handy. Kubernetes is an open source container orchestration platform that automates application deployment, management, scaling. It's also been described as a cluster management system, something that I had to learn as I was learning about Kubernetes, where it's taking our services and clustering them together to help things be a lot more efficient and easier to manage. As we talk about Kubernetes, we're going to cover a few concepts, enough terminology to explain what we're doing and how it relates to the flow of information. There is a lot to Kubernetes. It's a massive environment with many other nerd knobs and settings that you can configure while managing your Kubernetes clusters. So we're only going to cover what we need to know today to talk about Ingress and talk about Ingress with Consul. For starters, in Kubernetes, containers live inside of an object called a pod. For this diagram, we're only going to keep our pods on a one-to-one relationship with containers. So we're going to have one container running inside of each pod. So think of a pod as a sandbox for hosting containers. And in the spirit of abstraction, we're going to abstract out the diagram of our containers and just look at our pods now. It's almost like we're pulling the lens back from looking at containers, and now we're going to be looking at Kubernetes. And in Kubernetes, the smallest object, or the atomic object, I believe is what they call pods. Okay. And so pods, as we are building our application, we're going to be adding more pods. We're going to be adding more features. We're going to be scaling things. So we're going to have multiple pods in our application that are going to need to talk to each other. And with those pods, that communication happens through an object called a service. That's right, just a generic name like service. It kind of reminds me of that old programming joke, the 3 hardest things in programming: naming things and off by 1 errors. Yeah, you're welcome. Essentially, a service provides that ability for pods to communicate with one another. Think of pods as being on their own virtual private network where they can only talk to each other and no traffic can really get at them from outside. They're just the ones talking to one another on the inside of their cluster. This network traffic between pods is commonly referred to as east-west traffic. To allow outside traffic into the cluster, you need to configure something called ingress. And this is known as the north-south traffic. An ingress object uses one or more ingress controllers to set the rules of that communication. And an ingress controller can be one of several things. It can be load balancing the traffic that's coming at your cluster. It could be providing name-based virtual hosting. It could be providing authentication to that for accessing that cluster. Lots of controllers can make up Ingress and can provide different functionality. You can have one controller or many. So in order for Ingress to work, the cluster must have an Ingress controller running. I should say, in order for traffic to get to that cluster and for Ingress to work, it needs to have an Ingress controller configured and running. It's not going to be done automatically. There's a lot of other situations in Kubernetes where controllers are automatic and they spin up on their own as the application spins up. Ingress is not that way. Ingress is something that you have to specify through using at least one Ingress controller. So a common setup is to have an Ingress controller providing a proxy to the cluster. So we have an Nginx Ingress controller, and then another Ingress controller that's providing load balancing. So in this case, because it's orange on our screen here, we can assume that this load balancer is probably for Amazon, which illustrates the point that the load balancer is usually tied to the environment that you're running in. And so if I'm running this in Amazon, that's great. But if I want to take my application and for some other reason move it to another cloud provider, or maybe pull it in-house and into our own data center, our own machines, we'll have to configure another load balancer. We'll have to figure another Ingress controller to figure out how are we going to divvy up that traffic so we can balance the load coming in. But let's step back for a second and talk about ngrok and our journey. So ngrok started as a project by Alan Shreve when he was an engineer at Twilio. He needed a way to provide ingress to code running on his laptop. He was working with webhooks and he needed a place for those webhooks to go. As webhooks behave, they need an address that's publicly accessible to the internet to operate. They take their information, they send it to that address, and then that address parses whatever that webhook is sending. Well, Alan needed to provide ingress to his local machine and thought, well, I could go through the steps of setting this up on my machine, or I could make it something that I could just spin up a tool that does that for me. And then maybe it's not tied to this specific laptop, because what if I go to another laptop? I could have my own little tool that does this and provides that ingress. So he builds this thing and he gets excited about it, shares it with his team. They get excited about it. He shares it with the community. They get excited about it. And then people are actually like so excited, they want to pay him money for it. And he's thinking, wait, I could build a company around this. And as he's building that idea and thinking, all right, this is now going from hobby project to possibly a product that I could sell and have, build an organization around, I could have a software startup. And as many other software startups, he ran into that age-old architectural philosophical decision. The monolith or the microservice? Which way should I go? On the one hand, you have the monolith, which has a lot less infrastructure complexity, but it is also everything all in one place. It's super fast. And as a startup, speed is the name of the game. Getting features out, released, published. That's the part, that's the thing about a startup that you need to happen. That's most important. With microservices, yeah, your code's more organized. You have your concerns separated, true. And things take a lot more effort to launch. You need to put a lot more effort into your infrastructure. So he had a conundrum. He knew he eventually needed to go to microservices at some point, because as your organization grows, that makes a lot of sense to have a services-oriented architecture. So rather than making a solid decision one way or the other, Alan kind of went up the middle and came up with a hybrid idea. He called it the Neo monolith, or he also used the term Lego monolith, which I latched onto because I can visualize Legos a lot easier than a Neo. Who knows what that even is? So with the Lego monolith, you can imagine building blocks inside of a larger thing. You have that big purple box there in the middle. That looks a lot like a monolith. However, each of the services in that monolith are named the same. No matter how many monoliths, no matter how many boxes, VM images he has running of his application, they're all the same. The services have the same names, the same ports. And so there's no need for service discovery. There's no need for scheduling. There's no need for any orchestration complexity. He's able to easily scale because he can just replicate the boxes. And then yet also it's organized internally inside of each of those boxes in a way that he has a clear path to migrate to microservices when the time comes. So he took an idea that when he needed it, he could use service-oriented architecture, but he didn't have to have it straight up. It turned out nice. So as he built out the organization, as they started making decisions, and I say they because these are people that were at ngrok way before me. And so when they made these decisions to go to a service-oriented architecture, they started saying, okay, let's start adopting containers. We're going to start adopting Kubernetes. But in Kubernetes, we need to configure Ingress. Well, we have this product that provides great Ingress to developer machines. Why not also provide Ingress to production environments? Why not dog food what we have to see if other people could use the same benefit? They could use ngrok as a production tool and benefit from the ease of use that it provides. And they weren't the only ones who thought this. Actually, this diagram was created by users of ngrok and Kubernetes, not just, they weren't actually internal at ngrok. So we initially adopted a strategy that was a lot like this, where we ran ngrok, the agent, we took a binary of the agent and ran it as its own service. Remember, capital S service in Kubernetes. And it did something like this, where it essentially exposed an Nginx service, which in turn would expose everything to the internet. I mean, it worked, but it was a little weird, right? Not quite a sidecar, although others have done that as well, but definitely not the preferred way of doing things in Kubernetes. In our case, we still needed to write custom Go code to shoehorn the agent to work the way we needed it to. We even needed to change our own product. And users still needed to configure, or at least understand how to configure ngrok independent of Kubernetes, but then also know how they can make it work with the Kubernetes setup that they had going on. It wasn't a expected way of doing things where you have YAML manifest files, but a lot more work. Even internally, we went as far as creating our own custom instance of ngrok, and it started branching from the one that the world was using and the one that we're using. And suddenly, you're not dogfooding anymore if your product is different than the one that your customers are using. So it wasn't an ideal situation. We had a couple of decisions we needed to make going forward, essentially. We had to make some architectural decisions on our relationship with Kubernetes and how we would want to integrate with the Kubernetes ecosystem. But then also we needed to make some decisions inside of our product as well. So looking at the Kubernetes architecture and how we would connect with Kubernetes, we wanted to have an idiomatic API, which in other words meant we wanted to be able to behave as expected as the other Kubernetes controllers and objects. We also wanted to seamlessly, essentially hand in hand, right? We wanted to seamlessly integrate with Kubernetes and the Kubernetes ecosystem so that we could work well with clusters, but also work well with things like Consul, so that Consul provides great service mesh. Why not provide Ingress into things like Consul so that folks can easily connect their service mesh to the world? So those are some of the things we had to take into consideration for our connection with Kubernetes, but then we also had to make some product decisions. We needed to make some things available in our product so that our users had what they wanted while using our product. We needed to be able to provide load balancing. We needed to be able to provide encryption and authentication, and also not forget the webhook verification, which is where we all started. It's our bread and butter, and many folks are using it today. So we had to have these features in mind and make sure that those were part of the ngrok product itself before we could make it a Kubernetes Ingress controller. If you remember from a few slides ago, we talked about how ngrok worked, and it ran as an agent in the command line. So it's essentially running outside of your application. It's separate. It's pointing to the port that your application is running on, but it's still two separate things. So how do we get ngrok, the application, and embed it inside of an Ingress controller? So the controllers are written in Go, which coincidentally, so is ngrok. The CLI, running as an external process, needed to get inside of a Go application. So we had the idea of taking the concept, or taking the idea of ngrok and that functionality and bringing it into an SDK and combining them. so that you can have ngrok inside of your Go application code. This was able to make a tighter relationship between the application and the ingress it was needing to get out to the world. If you think about it, in Go, you have the net.listen API that essentially spins up a web server inside of a Go application. We took that same interface and decided, all right, so you return this object to create connectivity to a specific web server running locally. Well, let's take that object, and instead of creating a web server, we're going to create a tunnel connection with ngrok. So ngrok.listen is an object that allows you to dynamically spin up and spin down tunnels as needed. It allows you to have a high availability and uptime because it's running with your application. It's not a separate process now running in another terminal or another process outside of your application. It's actually running together with your application. It can react to Kubernetes events without having to tear things up or spin things up or tear things down. And it doesn't need to worry about an agent needing to entirely stop or start, depending on what you were doing with your ingress in your ingress connectivity settings. So thinking back to that diagram, we had that diagram before where we had the two controllers and it providing connectivity to a cluster. We have our load balancer, we have our Nginx Ingress Controller. But instead of those, you now have a solution where you have a single Ingress Controller that gives you access to load balancing, to encryption, to auth, to verifying webhooks. All of those things are in one place, and they're not tied to the environment where your Kubernetes cluster is running. They can be running locally on your box. It can be running in the cloud. It can be running on your own data center. And still, those settings remain the same. ngrok worries about the changes that happen behind the scenes, because those changes do happen behind the scenes, but all your traffic is being routed through ngrok, and ngrok takes care of all that. But remember, also, we had that goal that not only we wanted to be able to provide ingress to Kubernetes clusters, we wanted to seamlessly integrate to other objects inside of Kubernetes as well. So now, with things like Consul, you're able to integrate with Consul, because Consul and the Ingress Controller for ngrok both use Helm. They both use a lot of the same things that are needed for the ecosystem to work well together. In fact, you only need these two lines in your pod annotations to get ngrok into a Consul service mesh. This shows the power of following community standards and playing nice in the ecosystem. And other Ingress controllers you need to expose them out of the service mesh somehow at that point. But due to ngrok being able to create ingress into any network and even service meshes, it just works when you put in these two lines inside of your service intentions. There's a few things that we want to share through our development journey that we recommend you keep an eye on and get an understanding of if you are looking into building your own Ingress controllers or just other controllers in general inside of Kubernetes. First is the controller runtime. This is the set of standard Go libraries that are used for building Kubernetes controllers, and it's maintained and used by the Kubernetes project team. You'll get to know these by also using the KubeBuilder framework. The KubeBuilder framework is a launching point that really, really helped us in building our controller. It's used for building Kubernetes APIs using custom resource definitions, but then also provides those same framework benefits like providing logging, telemetry, things like that. And also it connects in with using the controller runtime. So keep KubeBuilder in mind if you're looking into building controllers, and then also the controller runtime. So one of the big trade-offs that we looked into and just discussed a lot was, do we make an Ingress controller or do we go with the next standard? The next standard inside of Kubernetes Ingress is something called the Gateway API spec. And the Gateway API spec is essentially a role-oriented API, and it is the standard going forward. However, there's a few reasons why we decided to go with an Ingress controller. The first is that it's the most widely used. If you look at the adoption rate, most users of Ingress in Kubernetes are using the Ingress controller. specification and Ingress controllers, essentially, and not gateway API spec. It's commonly already known. People know how to use it. They know how to configure with it. It's something that not only do we know, but also the industry knows. And so we wanted to introduce our new controller to a known way of doing things. That way folks can learn us. And then as they move forward and as we move forward, we'll do the gateway API in the future. Internally, it's what we use. When we set up Ingress inside of our own clusters, we're using the Ingress controller specification. Also, if you look at most of the gateway implementations, most of them are still in alpha, except for Hashi. High five to you at Hashi. Well done on getting yours out and outside of alpha. I think it's even outside of beta, so well done. But we figured if you look at all of those, it's okay that we went with something known first, and then going forward, we'll adopt the gateway API. The gateway API specs, as far as we understand, are still in flux as well. So it's a kind of a moving target. I know that the target is probably slowing down, but at this moment in time, we're still looking at the gateway API spec and making sure that that settles down first before we develop our own. In addition to it being the standard going forward, what we are excited about with the gateway API spec is the fact that it supports more than just HTTP and HTTPS traffic. We'd really be nice to have TCP traffic coming through with all the different types of network traffic that ngrok can handle. It'd be great to be able to also provide that ingress into clusters as well. As mentioned, it's the standard going forward. And also, as one of my engineers put it, it's everything Ingress is, just better. So the current status of the project is we recently, within the last few weeks, were able to go live with our general availability 1.0 version of our Ingress controller. We're super excited. And so internally, we're able to dog food it for using with our internal infrastructure cluster, our CI/CD processes, GitHub auth, let's see, our OIDC stuff, and also with Athens. Athens is a Go module proxy cache that serves all of our CI and local builds and passes. And so if it goes down, our whole CI goes down. And so that is essentially handling 80,000 requests a day. And that's all coming through our Ingress controller as well. And that's handling perfectly. So we love it. What's next in the project, as mentioned, is we are looking forward to adopting the gateway API spec. That's the future. It's definitely somewhere where we want to go. We just wanted to start with established specifications first, and then go into the future specifications. Some of the resources that you would find helpful are here. I highly recommend looking at the Ingress to Services in a Consul service mesh on Kubernetes. That's our integration guide with integrating with Consul. But also you have documentation on our Ingress controller, also the just general concepts of Kubernetes Ingress in general, and then the API gateway as well. Thank you all for listening. My name's Scott McAllister, developer advocate at ngrok. We'll be happy to continue the conversation about this or anything else you want to talk about. Just you can find me on one of these wonderful social media apps. Thanks.